If we actually search that, we actually get this result right here, and you could actually see the location. That's us right there, and you could see the record. I was hit very, very hard, so that gives us the record. So we can also search a whole bunch of other stuff here. So if we wanted to actually search, just let's say if we wanted to go to DC, let's see how safe DC is, and let's just search DC, and let's search around, let's see, what's a good place? Let's search around Georgetown. So let's go to Georgetown and let's look at robbery. And we could search robbery here and get a result. And whoa, we can actually get a lot of results right here. If you can see from our scroll bar, we actually get a pretty good number of results. And I forgot to mention, this list is actually sorted by spatial rank and date rank. Textual match is going to be the third choice in our ranking scheme, just because I think users are going to be more inclined to view the top of the list of the records, and those results are going to be records with closer proximity to the center location, as well as a more current date. So let's click this one right here. It says December 30th, 2008. There was a robbery at 3200 Prospect Street Northwest. So if we click that, we get centered on the crime. I believe it's that one right there. It says Prospect Street. So we can click it, and it just gives the full location, full description of the crime. If you see actually here, this data is actually quite clobbered. There are some XML errors in our data table because our description column actually allows you to put a very long varchar. Sometimes we have overlapping XMLs, and the whole entire contents of the XML is actually inside the description. So actually you can see here the entire the crime number, the shift, the method, the last modified date, everything is actually here. And if you go to the record, you see the exact same thing. Like, here's the individual individual database columns with the correct data, and then the description is just, for some reason, they flooded the XML again. The only data points we cleared out of our database table was those points with invalid latitude longitude schemes, as well as for some of the numbers ones, such as latitude and longitude, sometimes they would be like strings. So those are the only invalid data points that we got out of our database table. So another thing which we implemented as part of our feature, since this is a mobile crime application, it's not a mobile crime, this is a mobile application which allows you to detect crime, is the ability to detect current crime. So what we originally wanted to do is set up a push notification system, which would allow you to be notified of crime when this application is running in the background, so not when it's open. We didn't get to implement that, but we did get to implement an APB listener, which allows anytime you are in this application to be alerted to new crime. You see right there in the bottom, there's the alerts button, and it's actually currently grayed out right now. If you could tell, options, report, and view are not grayed out, and alerts is grayed out. So if a crime were to happen, this is not real crime, obviously, this is a generated crime, so if crime were to happen, we would get an APB result like that. So you saw that. It showed us a quick description of what the alert was. It says stolen pizza, and the alert button has now, if you can see that, says new alert. So we're going to click new alert, and this actually populates our result list with the new crime. So we're going to click on this result right here, and our map's going to center to the location point, and the crime is actually where we are. So let's see what's going on. Let's click the button right here, and it actually says the description is man ran off with multiple pizzas, claiming don't worry, it's for science. If we click the view records, we actually get the entire contents of what that crime was. And so it happened April 29th at around 2:30 p.m. And we actually have the picture of our suspect right here. You gotta look out for this guy and his fingerprint right here. So this is just this is the only record we implemented which has picture and fingerprint data, because this is our own test data. So this is not real data. Obviously, this is our professor, and we get him in a lot of trouble if we actually put him out in a real crime. So we also have clustering showing for k-means. For our clustering, for data mining prospect, we have clustering uses simple k-means from Weka. How we display that is we have a clustering button you can access from the options page. So if you go to the options page right here and click clustering, and this will gather all the k-means clustering points we have from our data set. And to display this, we go back here and click on the View Map button. And this will display, we only use the Washington DC dataset, but as you can see, these are the clustering centroids that are gathered from k-means. And let's see, this is only the DC data, but if you click any of these points, it displays the type of the category of crime, as well as the number in that area. So there's larceny, and here is larceny again, and larceny. Like mentioned before, larceny's pretty popular. Larceny/theft is one of the largest crime datas we have, and pretty sure actually all these are larceny. Yep, so all these data clusters are larceny. So thank you very much for watching the crime mobile spotter from Yida, Mathew, DeWitt, and Fritz. Thank you very much.